Yeah, it's very exciting from the keynote today, talking about quite a bit about structured streaming. So just happened to hit naturally what I'm going to talk about today, and you can actually hear more of the details, how some of the things works. It's completely unplanned. So, okay, so we're going to talk about SSR. SSR, I think I might have the wrong slide. Okay, so all joking aside, we're talking about Spark and R. Before I start, I want to have a quick disclaimer. What I'm going to talk about today, obviously, is contributed by the Apache Spark community. But a little bit about myself. I've been working with streaming on and off for 4 years, R for 2 years, machine learning here and there. But I've been also presenting at different meetup conferences and so on, and I've been trying to really build a very large-scale data system. So today, this is gonna be a little bit of a personal journey for me, since I've been kind of working with streaming for quite some time. So we're gonna start with structured streaming. We're gonna touch on ML pipeline. And we're gonna talk about how R could actually put all that together and also supporting structured streaming, plus some machine learning use cases. And then a little bit of a trick I discover, maybe the rabbit is already out of the head, so we'll see what happened when we already know after the keynote. All right, streaming. So can I ask for a quick show of hand how many of you actually are using Spark streaming for more than a year? There's quite a bit, actually. How many of you actually use structured streaming? Quite a bit? Great, maybe just a little bit. How many of you actually use R or on maybe a day-to-day basis? Great, cool, wow. It's much more R people than streaming people. That's good, actually, because a lot of this is going to be in R. All right, so why streaming? Why do we even care? So a lot of it is really to the fact that people really want fast, quick insight really fast. They want to see things coming in. They want to know what's going on. They want to do either ETL on the data, the cleaning and things like that. They want to look at trends. They want to look at things like look at triggers, anomaly detection, know when things happen, right? Or it could be that, oh, I've got all these latest data coming in. I want to be able to actually join with the existing data I have and do some checking or get some insight out of that. And the very last part is continuous learning. So Spark streaming, we really add the third generation of Spark streaming. At the very beginning, there's a receiver model, and then soon after that, there's the direct D-stream model. And then now we have structured streaming. So the good things about the third generation, being in the third generation, is the fact that a lot of the problems or worries are already taken care of for you. So a lot of these things are now at a very much higher level that you can just work with easily without having to worry about if I'm going to lose something or not. So structured streaming. So in structured streaming, what we're really trying to do is we take the batches from the data stream, what you see on the left-hand side here, and each of these batches turn into new rows in this unbounded input stream. So think of it as conceptually things are structured, has a schema, has a structure, it maps to a table. These new batches coming in as you run the streaming job turns into rows. That just kind of backfill into the table as you go along. So structured streaming has a streaming logical plan. The idea is it takes the data set and data frame and include bring on top of that the notion of incremental execution on these new input batches coming in. So you get this streaming data frame, and then the execution happens on an ongoing basis based on the trigger. It's basically rinse and repeat. This is actually a washing machine there. So the same stuff you can do, transformation, map, filter, aggregate, window, join with some limitation on what you can do right now. But there are better things too. How trigger you can configure, consistency guarantee, fault tolerance is already built in, and event time processing for late data. and with watermark, it's built in. It's all magic. But still, at the very core of it, there's still the execution plan. There's the logical plan, physical plan, but the catalyst optimizer is still in, but it's just operating at a smaller scale on each of the batches you have. So let's kind of take a look at what is structured streaming and how all the pieces fit together. To start with, you have a source, right? And then you have a trigger that runs the source. From the source, you get something that you feed into a transform, an arbitrary number of transformation you want to do. And then into the sink, where it actually get written to somewhere. So that completes sort of what I call a circuit, cutting from the source to the destination, and how many hops and knobs you have, and that's totally fine. And all of that is lazily executed, and each of the step is kind of, interchanged using the data frame, the object model that you have. So all of that remain the same. And then you just basically repeat this process in each of the trigger points you define. So that's basically, at a high level, my view of how structured streaming works. With all the sources, there are a couple of sources we support in structured streaming today. We have file source, Kafka, text socket, MQTT as a form of external package. And then these are the sink we support today. They're file, console, memory for each is kind of advanced case. And new in 2.2 is the Kafka sink. So you can take data from Kafka source, do your transformation, and then write it back to Kafka as well. One thing, if there's anything else that you need to be aware of, is if you're implementing solution using structured streaming, is this notion of output mode. A lot of these other things are already taken care of for you. There's good default value and things like that. But like output mode is probably something that you should at least keep in mind before you start kind of thinking about building solutions of structured streaming. And the reason why is it sort of partition your or divide your output in the different modes that is actually described here. For example, when you set your output mode to append, that means only the new stuff actually get written to the sink. When you say complete, then every single one of these iteration that runs, it will actually have the complete set of data. And then when you have update, which is new, it will only output what's actually changed. And particularly, it works mostly with lay data, with watermark, that sort of stuff. So as you can probably tell, with complete mode, you can't really, it's not conceivable to actually keep all the data around forever, with the unbounded data stream. So output mode complete only works with only works with execution plan that has aggregates. So streaming and ML actually don't really mix really well, even though that's the kind of the crux of this talk. Well, kind of. So there's an early iteration of streaming ML. We're going to ignore that for a bit for various different reasons. But I'm going to talk about how conceivably this could work. So this is an ML pipeline. So generally, you start with a data frame. You apply it to a transformer. You could be tokenizing the input text you have. And then you pass it to another transformer, say hashing it in general. And then you pass it to a logistic regression to build a model out of this. So there's the feature engineering phase and there's modeling phase. And generally, the output of this is a model. The model could be applied to additional new data. It's kind of good circular, cascading kind of flow kind of thing. The problem here is if you look back at the structured streaming flow that we talk about, right? It starts with a source. You can pass it through any arbitrary number of transformation, and then you pass it to a sink. And every step of the way, we expect to use a data frame. It doesn't work with model. So here's the problem here. So you can't fit the ML pipeline into this. So like I said, the pipeline fit method that actually result in a model is essentially an action. And the structured streaming sink start method also is an action. If you remember the good old days, RDD and action and transformation versus, how they're different and so on. Basically, this is what kicks off the lazy execution. So structured streaming circuit must be completed using the sync start method. So you can't really just jam the ML pipeline into this pipe. So R is here to rescue. Well, so what is this R stuff? So many of you have been already using it, hopefully. So it's a statistic language for statistics. It has over 10,000 packages on Crane, which is amazing. And why do we even care about streaming in R? One of the things that I've kind of learned about talking to people with different companies and so on, and people care about having one way of doing things. Obviously, sometimes it doesn't work out that way, but a lot of times people want to say, hey, I want something that could ingest data, do the ETL and cleaning and transformation in the way that I want it, and then do the machine learning in the context of the same thing. And the reason why you want to do it that way is one job versus multiple of these, for example, like maybe 3 different jobs of doing these, is you don't have to worry about like synchronizing all your job and make sure they are like executed in an atomic kind of manner. If something failed, then things get proceed in the proper way, not reporting the wrong stuff, that sort of thing. So that makes it much easier, and you can do that in Spark, right? You can actually do your ingestion with different data sources, do your transformation the way you wanted it, even persist the intermediate data for other needs, other jobs, and so on. But then you can pipe it to like machine learning, do processing for outputs for insight that you're looking for. Another reason why you want streaming in R is that, or just machine learning in R, is that I want to be able to use my existing packages. My favorite packages, I know how it works. I know the theory behind it. I know how it would behave in this case. I've just been really used to that kind of thing. So this is kind of what I'm going to describe how this is going to work. So, and what Bill was talking about actually, so, there is a package for connecting R to Kafka, but it's actually kind of dated. It's kind of last published in 2015. I'm not sure what happened to it, but it's kind of been around for a long time. So SparkR, or structured streaming in R. So SparkR, the idea with SparkR is you take the data frame API, you implement a set of data frame API to make it look like the R data frame API set or deployer API set, but leverages the full Spark Catalyst engine, Tungsten engine, all these other optimization you get, and run it on a cluster. It supports the same thing that you would expect: SQL, session, catalog, Spark packages, machine learning. There are 2 things I want to highlight though, is the R native UDF, which we're going to talk about in a bit, and structured streaming. So R native UDF. So UDF is basically user-defined function, custom transformation you can write in R code that you want to apply to the data set you have. The way this works in SparkR, we support 2 different forms of it: apply by partition and apply by group. The way this works underneath the cover is you define UDF. We're going to take the data set, convert it into the native R data frame, pass it to your UDF so that your code would execute, and then we expect to get back the R data frame back. So in terms of this big data set you have, right, you start with this data already in a smaller partition, and for each of these partitions, we're going to pass it along separately to these R process and run your UDF and expect to get back the data frame back. That's kind of how it parallelized the operation itself. And a little bit of a plug for earlier talk back in February, Spark Summit East, talk more about the details of how that works and the caveat of each of these stuff. But how this actually works then? Because we've been talking about RUDF and structured streaming, all these things. So we call the way the UDF support works is that it actually really just behaves like any kind of transformation. It takes a data frame, apply your transformation in native code, in native R code, and then it has to return back a data frame, right? So if you look at the circuit we were talking about, it plugs nicely into that middle part here. It's basically, we just say, hey, here's the source, here's the arbitrary transformation, in this case, the RUDF, and then to the sink. So that actually works around the problem with ML pipeline, which doesn't actually work that way. The output is a little different and so on. So structured streaming support in R was implemented essentially with 3 different set of things. We have the stream reader and writer. We have the streaming query, which is how you can actually get status and operate on the streaming action itself, whether you want to stop it, start it, and things like that. And there are a few small incremental extension to data frame itself, so you can actually know what you're working with. So I'm going to quickly jump to a demo now, but before I go to the demo, I just want to quickly highlight kind of what's going to be in the second part of the demo, essentially, is we're going to actually create a job that's going to discover trending topics on news coming in, news headline coming in. And it's going to use structured streaming, it's going to use machine learning with native R package in the UDF. So let's, okay. I can't see my cursor here, so it's gonna, oh, okay. All right, so this is smaller than I thought it would be. So let's see if I can make that better. So what I have here is, okay, let's move on. So what I have here is a Kubernetes cluster running Kafka and Spark. So I'm starting a SparkR shell with the Kafka jar, Kafka packages, so it's going to load the transitive closure, all the dependency in there. And then to start with, I want to actually start with something simple, like reading from JSON dataset, right? So I'm going to read from existing dataset I have. I can print schema. I can dump the data a little bit and see what I'm dealing with. I can also subset it using the very familiar operator in R with the column and the row that I want. And I can make up some data set as I go. So this is just to test what I'm gonna do next, which is I'm gonna join these 2 things together using the merge function. So merge is gonna automatically detect the columns that can join together, and it's gonna name these columns in this form that you see here. And then I can also take existing data set, like from this flight data set. I can aggregate it, I can do a count on it. Or I could use another library like Migrator for pipe. So I can pipe the transformation in a sort of a functional programming type of manner here in R. Do group by it, aggregation, and so on. So we were looking at reading data from JSON, right? So reading from stream is very similar. So you can see here we're reading from Kafka. The data set we're getting back, we only care about the value column, and then we're dumping into console. So let's start the console producer in a separate test node. And I'm gonna type some words here. You see it actually pops up immediately. And I can type some more and it's gonna show up. So each of these batches is dumping into this console thing. And I also check if it's the data frame is a streaming data frame. I can look at the query itself to look at the execution plan and to check to see if it's running. And I can type some more and then dump some more data as I go. Let's stop that for a second. I'm gonna switch to a second demo here. I'm gonna read from the Kafka stream again. I'm gonna actually, again, I'm gonna have to take the value column and turn it into a string. So what I'm doing here is a little different. What I'm actually doing here is I'm take the value column, split it by space, expose it into a column, and then doing a count on it. So I'm doing a streaming word count in 5 lines. So in this case, I can type stuff with space now that I handle space. And then you can see here, that's gonna pick it up automatically. And then, oh, so nothing happened. What happened? So I actually changed to a memory sync in this time. So in memory sync it becomes temporary table. So I can run SQL query on it. I can do it again. I can dump more data. I added a C again. So you can see the second time around, there's one more C here. So doing word count on the fly. I can do all sorts of SQL query as I like to do as well. Check the status of the job. Right now it's waiting for data. There's no data coming in. And then let's stop that and move on to the UDF part we were talking about. So with UDF, let's define kind of the structure of the data set returning from the UDF. I'm going to call dapply, which is kind of the mechanics, the function for supporting UDF. I'm going to call this native library, load this native library called rtexttools, which is very useful for creating document term matrix. I'm going to be calling into LDA from topic models too, to do some topic modeling around this. I'm going to make a guess on how many topic based on the amount of data set I have. But the important thing is I want to return that as a data frame, right? A native R data frame with the right name and returning from the anomaly function in there. And then I'm going to do a group count on that term. So essentially what I'm doing is I'm doing a topic modeling on the input data stream set, which I'm dumping it into Kafka right now, which I'm going to pick it up on the other end, and doing a word count on that the topic that returned back. So if I dump the data set, another data set here, you can see some of that aggregate up with multiple counts. So what I can see is I can have these streaming job runs, and then I can see how the trending topic is going to aggregate by the highest count. The other thing I can do also is write the data, take the same line that is defined previously, and write it into this. And I can also do something like check the last status on this. It's kind of hard to see what I run. But let's just dump more data in there. I'm going to see that the offset is going to increase. And you can see here, it's going to say the description here has a streaming output as is this job, what is running. And also a wait for termination. If you're running this as a job, you can do it. And I'm going to show you basically the data, Parquet data that get written by the few lines of code that I had there for a while. So that's it for the demo. This is going to repeat itself. All right, so back to the slide. OK, that was a really quick one on the demo itself. But one thing I want to highlight here is we were talking about streaming word count and all these fancy things you can do. With the pipe construct you can get from MacGradle, you can actually do this streaming word count in a single line. I'm not sure you can do any of that in any other language other than R. So you can take the restream, and then what that does is it pipe that to the second line, which is doing this select SQL expression to say, hey, I want to split this value into with the spaces and explode that into multiple rows. And then I'm going to group by that particular column, and I'm going to do a count on that, and that's my streaming word count. For simplicity's sake, I'm just dumping it into the console, but you can dump it into like a file as well, or another table, and that sort of thing. So some of the challenges here. So, well, it's really more a consideration, I guess. So I think we talked about that at the very beginning. Streaming in ML is not really good bedfellow, I guess, right now. Streaming is really mostly dealing with small packages and stuff, right? Machine learning usually deal with large data set, or at least you need to have some decent size to train a model. So one way to circumvent some of that is maybe you should pre-train a model. So you can pre-train a model and pass it to UDF, and you leverage a pre-trained model that way. Or you can actually use a package that supports something like online machine learning for things that you can actually build a model as you go. The other thing you need to be aware of is mostly around streaming, I guess, is that how do you adapt to data schema changes? If you have data stream that's continuous on a 24/7 basis, sometimes it changes. So you need to be aware of that. And sometimes the behavior or the pattern on the data itself changes. So the model might not work anymore. And that brings to the last part, which is sometimes you need to update a model. So, and also a little bit more about the demo. Obviously, with a more practical implementation, you probably don't want to be using LDA. You probably want to be using something like LSI, which support online training, or maybe the online variation on LDA as opposed to just LDA on a small batch of data. Other things like KNN could also work. If you have a k-means implementation, that can work with taking the existing cluster and then apply it to a new data set, that could also work. And then a little bit of a structured streaming consideration. One thing, just we sort of glanced through that through the really fast, quick demo, but the data frame that get returned from the data stream reader has this schema, basically has this schema of key, value, topic, partition, offset, timestamp, and so on and so forth. But the key and value field are in the object type, so you need to make sure that you convert it into the right type before processing, like what we did. The other thing here is what we talked about already, the output mode requirement. Do you know what is the granularity data that you need? What is the aggregation level that you can work with? You need to think it through before you start. The other piece to consider is doing ML with our UDF. Native UDF can break the job if it starts throwing exception or actually just stopping the job itself. Some of these ML packages are pretty sensitive with empty data and so on, so which could happen when a streaming kind of scenario. The stream package you come in might have just an empty line, it might not actually work. So practical implementation is you actually need to put in a lot more data check and kind of filtering empty line, that sort of thing, before passing it to the packages you have. The other thing also is debugging this could be kind of challenging because is this happening in a UDF in this cluster somewhere kind of far away. So you might want to actually run that UDF separately, locally. But the nice thing is you can, right? So you can just feed the data in, turn it into our native R.data frame, and just call UDF locally. And then you can make that a Spark job after that. And the other last two things to be aware of is UDF must return a data frame that matches the schema you defined. One of the kind of frequently run into trouble here is it doesn't actually quite match, and we kind of run into the problem try to understand what data is getting returned. So you need to be really careful about that. The other thing also is last thing I mentioned, which is when you're dealing with streaming machine learning, you might want to actually just save off a model and then distribute a model instead of just building a model as you go. It doesn't really work that well that way. So and the very last thing I want to talk about is kind of the future of this, and I'm really looking forward to any kind of feedback and whether we're heading the right direction and that sort of thing. People even like what we're doing here with streaming and R, which is kind of a strange combination. But we're going to be adding potentially like support for trigger and watermark support for lay data. That's it, and I'm open for questions. We have a few minutes.
Yeah, let's give them a round of applause first.
Thank you.
So for questions, just come on, step up to one of the mics, and go ahead and ask your question.
No question. Great.
I got a question. How's the, what kind of challenges did you come across, especially in implementation? And for the people that have just gotten started with this, what are kind of, you mentioned handling the schemas like a big challenge. Is that kind of the biggest challenge that people come across? I guess, how easy is it to get started?
So there's definitely a little bit of a mental leap because we're dealing with